Hi everyone. In this tutorial, we're going to learn how to use Robert with one of the examples from the Read the Docs webpage. If you haven't installed the program, first install it with the instructions from the installation group of tabs, and then you can follow the example. The first thing we need to do is open the Read the Docs documentation, and then go to the full workflow from CSV tab. To reproduce the example, go to the Executing the Job tab. Then we follow step 1 and go to the Required Inputs tab. Here you can download the database just clicking in this icon. The database, and as you can see over here, the first column is called name and contains the names of the compounds. Then there is a column titled target values with the target or Y values that we want to use in the model. The rest of the columns contain the descriptor or X values to use in the model. Going back to the Executing the Job tab, now step 2 asks to go into the folder containing the CSV database in our terminal. For this, we need to type cd, write the path to the folder where the CSV database is, and finally press enter. In step 3, we need to activate the code environment of Robert. For this, we just need to copy this command, paste it in your terminal, and press enter. You should see the Robert environment activated over here. Next, we just need to run the command shown in step 4, copy it, paste it in your terminal, and then press enter. Now the program takes a few seconds to load different Python libraries before it starts running. Then when it starts running, it performs the data curation protocols, then it screens different models and so on. After the program finishes, a PDF report is created containing a summary of the results. After the header, we can see a section titled Robert Score, which shows the Robert scores of the two optimal models found. And the score indicates the predictability of the models in a scale from 0 to 10. Then it shows the predictions of the model and also gives you a web page where you can check how the Robert score is calculated. Below that section, there are some tips to improve the score and then instructions to predict new values with these models. The next part is the reproducibility section with the files that you need to reproduce the results in step 1. Then step 2 shows the programs that you need to install with the corresponding versions. This step also indicates whether the scikit-learn Intellex code accelerator was used. Step 3 shows the command line that you need to reproduce the results. Just copy the line, paste it, and execute it. And finally, step 4 contains some information about the Python version used, operating system, and the execution time of the job. The next part is the transparency section. Step 1 shows the type of algorithm and parameters used in the two models. In one case, it was a neural network, and in the other, a linear model. Then, step 2 gives information about internal Robert protocols, such as type of data splitting, type of supervised problem, and the type of error used during model optimization. Then a short section with abbreviations, and the section summarizing the results from the data curation model. You can see here a Pearson correlation heatmap with descriptors. The generate module comes next, showing matrices of models from the combination of partition sizes and hyper-optimized algorithms. There are two matrices, one for each model. Then the verify module, which analyzes the performance and reliability of the machine learning predictors. The tests include cross-validation, Y-mean, Y-shuffle, one-hot encoding test. If you want more information about these tests, you can visit the online documentation of the supporting information of the Robert publication. Next, the predict model shows the number of points used for training and validation with their proportion, the number of descriptors, and the ratio of points and descriptors. It also shows different metrics of the train set and the validation set. Here, a section with all the outliers found. In this case, compound 21 is the only outlier with an error of 3.4 standard deviations. This graph displays a sorted list of variables and their effect on the Y values, measured with sharp feature analysis. In this case, the most influential descriptor is X10. And below, there is another feature important analysis, this time with permutation feature importance or PFI. And finally, the outlier analysis, where you can see how the errors of your results are distributed and spot outliers easily. That's all for this tutorial, but if you want more information about the program or the examples, please visit the online documentation. Also, if you have any questions, problems, or want to implement a new workflow, feel free to reach out to David or I by email, or just open an issue in the GitHub repository.